Let R be the region bounded above by the graph of the function f of x equal 1 minus x squared, and below by the y-axis. Find the centroid of the region. So first, let's take a look at the graph of this f of x. F of x is the parabola open downward with the vertex at 0, 1. And this is not to scale. And as you can see, the graph of f of x is symmetric with respect to the y-axis. So we would expect the centroid of this region is fall on the y-axis. Okay. So first of all, let's calculate the mass. The mass equal to the integral from -1 to 1 of the function f of x, that is 1 minus x squared dx. This is x minus 1/3 x to the third. Evaluate from -1 to 1. That is 0. The moment with respect to x equal the integral from -1 to 1 of 1/2 times the function square. So this is 1/2 the integral from -1 to 1 of 1 minus 2x squared plus x to the 4 dx. Evaluate this integral, we get 8/15. The moment with respect to y is the integral from -1 to 1 of x times f of x. And this is the integral from -1 to 1 of x minus x to the third dx. Evaluate this, we get 0. Let's check our mass. So we have 1 minus 1/3, that is 2/3, minus -1 plus 1/3, that is -2/3. So the mass is 4/3. So mass of that lamina is 4/3. Now, here then we already have our mass. We have our moment. We can find the centroid. X bar equal the moment with respect to y divided by the mass. That is 0 divided by 4/3. That is 0. Y bar is equal to 8/15 divided by 4/3. And that is 8/15 times 3/4. So simplify this a little, you get 2/5. So as we can see, the centroid of the symmetric lamina is on the y-axis. The next thing we take a look at is the theorem of Pappus volume. Let R be the region in a plane, and let L be a line in a plane that does not intersect R. Then the volume of a solid of revolution formed by revolving R around L is equal to the area of R multiplied by the distance traveled by the centroid of R. Now the proof for this is provided in our book. So make sure to take a look at it. We will use that in an example to calculate the area of this torus. Let R be the so-called radius 2, center at 0, 4. Use the theorem of Pappus for volume to find the volume of the figure. The region R is the so-called radius 2, so the area of this region equal to 4 pi r squared. Equal pi r squared. So the area of the region equal pi r squared. The so-called radius 2, then we have pi times 2 squared, that is 4 pi. By the symmetric principle, the centroid of R is the centroid of the circle. So then the centroid travels around the y-axis in a circular path of radius 4, which means the centroid is travel at the distance of the circumference, which is 2 pi r. So the distance travel the distance of 2 pi r, and that is 2 pi times 4, that makes 8 pi. So then the volume of the torus is equal to the area of the region multiplied with the distance traveled, that is 4 pi times 8 pi, that's 32 pi squared unit cube.